Hello, Mr. Price here, and this is the January 2006 video, and this will be on question 6. And this question is all about another projectile question. They seem to like putting a few of these in a question, so let's have a look. A stone is projected horizontally with a speed of 7 meters per second from a point on the edge of a vertical cliff. And the horizontal and upward vertical displacements of the stone from O at any subsequent time t are x and y respectively. And we're going to assume there's no air resistance. So the first part of the question is asking us to express x and y in terms of t and then show that this is true. So just like all projectile questions, we're going to start off with two equations for the horizontal and vertical motion. And to help us do this, we're just going to model the question like so. We're projecting our particle horizontally at a speed of 7 meters per second above a cliff. Okay? So, initially it starts with no vertical speed. And we know the displacement of this is going to be y. Okay, so if we resolve upwards, we start with no speed in this plane. We'll accelerate at negative 9.8 meters per second squared. Our displacement, we're told, is y. Okay, we need to use the variables that are given to us. And our time is going to be at t. Okay, because it wants it in terms of y displacement and time. So that's what we're going to do. Okay, so using s equals ut plus half at squared, we get the y displacement is equal to 0 lots of t plus negative half of 9.8, so negative 4.9 t squared. Okay, now if we resolve horizontally now, we can just use, we know the speed is 7 meters per second. Our displacement is x, our x displacement, and time equals t. So in order to make this one equation, we've got t that links to both of these. So we'll get an equation involving time. So time is a displacement x over a speed 7. And let's call this 1 and this one 2. And all we're going to do is sub 1 into 2. And the t's will cancel out and we'll get an expression in terms of the y and the x displacement. So y equals negative 4.9 lots of x over 7 squared. So this gives us y equals negative 4.9 x squared all over 49, because 7 squared is 49. And then we can simplify this, so y equals negative x squared over 10. And this is exactly what we wanted for part I. There we are, we've got it. Okay, that's part I. Let's look at part 2. Now for part 2, we're told that the stone hits a sea at a point which is 20 meters below the level of O. We want to find the distance between the foot of the cliff and the point where the stone hits the sea. So effectively, if we've got our cliff here, it has 20 meters to travel downwards. We want to know, it's going to follow this motion. We want to know this distance here, x. Okay, so using at y equals 20, so in other words, negative 20. So this is our datum position here. So this is at y equals 0. So we want the x displacement when y is at negative 20. So using our original equation, we've got negative 20 equals negative x squared all over 10. So dividing through, multiplying by 100 and dividing by negative 1, we get 200 equals x squared. So x equals 10 root 2 meters, or 14.1 meters. And that's it for part 2. Okay, part 3 now. We are now being asked to find the speed and direction of the motion of the stone immediately before it hits the sea. So, at the point where it hits the sea, there's going to be a horizontal speed, which we conveniently already know because this is not changing. So this is going to be 7 meters per second. And there's also going to be a downward speed. So its overall speed is going to be coming in like this, and we want its angle to the horizontal. So all we need to do is work out what this speed is. So resolving upwards, we know the initial speed is 0. Acceleration is negative 9.8 meters per second. We want the final velocity, and we know it needs to travel downwards by 20, so s is negative 20. Okay, so using v squared equals u squared plus 2as, we get v squared equals 2 lots of negative 9.8 lots of negative 20. So we get a velocity here of 14 root 2. So we know this is 14 root 2 now. So all we need to do using Pythagoras is get this value here. We'll call this speed. So speed squared is equal to 7 squared plus 14 root 2 squared, square root both sides. So we should get that to be a magnitude of 21 meters per second. And then just use trigonometry to get the angle. So we'll use the original values that we've got here. We won't use this one. So tan theta equals the opposite over the adjacent, 14 root 2 over 7. So using inverse tan, you should get a value of 70.5 degrees. And that's job done for question 6.